JS documentation. My understanding of Unreal Engine 5's gameplay ability system plugin, GAS, with a simple multiplayer sample project. This is not official documentation and neither this project nor myself are affiliated with Epic Games. I make no guarantee for the accuracy of this information. The goal of this documentation is to explain the major concepts and classes in GAS and provide some additional commentary based on my experience with it. There is a lot of tribal knowledge of GAS among users in the community and I aim to share all of mine here. The sample project and documentation are current with Unreal Engine 5.3, UE5. There are branches of this documentation for older versions of Unreal Engine, but they are no longer supported and are liable to have bugs or out-of-date information. Please use the branch that matches your engine version. JS Shooter is a sister sample project demonstrating advanced techniques with GAS for a multiplayer FPS/TPS. The best documentation will always be the plugin source code. 1. Intro to the Gameplay Ability System plugin. From the official documentation, the Gameplay Ability System is a highly flexible framework for building abilities and attributes of the type you might find in an RPG or MOBA title. You can build actions or passive abilities for the characters in your games to use, status effects that can build up or wear down various attributes as a result of these actions, implement cooldown, timers or resource costs to regulate the usage of these actions, change the level of the ability and its effects at each level, activate particle or sound effects, and more. Put simply, this system can help you to design, implement, and efficiently network in-game abilities as simple as jumping or as complex as your favorite character's ability set in any modern RPG or MOBA title. The Gameplay Ability System plugin is developed by Epic Games and comes with Unreal Engine. It has been battle-tested in AAA commercial games such as Paragon and Fortnite among others. The plugin provides an out-of-the-box solution in single and multiplayer games for implementing level-based character abilities or skills with optional costs and cooldowns, gameplay abilities, manipulating numerical attributes belonging to actors, attributes, applying status effects to actors, gameplay effects, applying gameplay tags to actors, gameplay tags, spawning visual or sound effects, gameplay cues, replication of everything mentioned above in multiplayer games. GAS provides support for client-side prediction of ability activation, playing animation montages, changes to attributes, applying gameplay tags, spawning gameplay cues, movement via root motion source functions connected to the character movement component. GAS must be set up in C++, but gameplay abilities and gameplay effects can be created in Blueprint by the designers. Current issues with GAS: gameplay effect latency reconciliation, can't predict ability cooldowns, resulting in players with higher latencies having lower rate of fire for low cooldown abilities compared to players with lower latencies. Cannot predict the removal of gameplay effects. We can however predict adding gameplay effects with the inverse effects, effectively removing them. This is not always appropriate or feasible and still remains an issue. Lack of boilerplate templates, multiplayer examples, and documentation. Hopefully this helps with that. Up arrow back to top 2. Sample project: a multiplayer third-person shooter sample project is included with this documentation aimed at people new to the Gameplay Ability System plugin but not new to Unreal Engine. Users are expected to know C++, blueprints, UMG, replication, and other intermediate topics in UE. This project provides an example of how to set up a basic third-person shooter multiplayer-ready project with the Ability System component, ASC. On the Player State class for player/AI-controlled heroes and the ASC on the Character class for AI-controlled minions. The goal is to keep this project simple while showing the GAS basics and demonstrating some commonly requested abilities with well-commented code. Because of its beginner focus, the project does not show advanced topics like predicting projectiles. Concepts demonstrated: ASC on player state versus character, replicated attributes, replicated animation montages, gameplay tags, applying and removing gameplay effects inside of and externally from gameplay abilities, applying damage mitigated by armor to change health of a character, gameplay effect execution calculations, stun effect, death and respawn, spawning actors, projectiles, from an ability on the server, predictively changing the local player's speed with aim down sights and sprinting constantly. Draining stamina to sprint, using mana to cast abilities, passive abilities, stacking gameplay effects, targeting actors, gameplay abilities created in Blueprint, gameplay abilities created in C++, instanced per actor, gameplay abilities, non-instanced gameplay abilities, jump, static gameplay cues, fire gun, projectile impact, particle effect, actor gameplay cues, sprint and stun, particle effects. The hero class has the following abilities. Minions do not come with any predefined gameplay abilities. The red minions have more health regen while the blue minions have higher starting health. For gameplay ability naming, I use the suffix _BP to denote the gameplay ability's logic was created in Blueprint. The lack of suffix means the logic was created in C++. Blueprint asset naming prefixes 3. Setting up a project using GAS. Basic steps to set up a project using GAS. Enable Gameplay Ability System plugin in the editor. Edit your project name, build.cs to add gameplay abilities, gameplay tags, gameplay tasks to your private dependency module names. Refresh/regenerate your Visual Studio project files starting with 4.24 up to 5. 2. It is mandatory to call uAbility System globals, get.init global data, to use target data. The sample project does this in uAsset Manager, start initial loading. This is called automatically starting in 5.3. See init global data, for more information. That's all that you have to do to enable GAS. From here, add an ASC and attribute set to your character or player state and start making gameplay abilities and gameplay effects. Up arrow back to top 4. Gas Concept Sections 4.1 Ability System Component 4.2 Gameplay Tags 4.3 Attributes 4.4 Attribute Set 4.5 Gameplay Effects 4.6 Gameplay Abilities 4.7 Ability Tasks 4.8 Gameplay Cues 4.9 Ability System Globals 4.10 Prediction 4.1 Ability System Component. The Ability System Component, ASC, is the heart of GAS. It's a U-actor component, U-ability system component, that handles all interactions with the system. Any actor that wishes to use gameplay abilities, have attributes, or receive gameplay effects must have one ASC attached to them. These objects all live inside of and are managed and replicated by, with the exception of attributes which are replicated by their attribute set, the ASC. Developers are expected but not required to subclass this. The actor with the ASC attached to it is referred to as the owner actor of the ASC. The physical representation actor of the ASC is called the avatar actor. The owner actor and the avatar actor can be the same actor as in the case of a simple AI minion in a MOBA game. They can also be different actors as in the case of a player-controlled hero in a MOBA game where the owner actor is the player state and the avatar actor is the hero's character class. Most actors will have the ASC on themselves. If your actor will respawn and need persistence of attributes or gameplay effects between spawns, like a hero in a MOBA, then the ideal location for the ASC is on the player state. Note, if your ASC is on your player state, then you will need to increase the net update frequency of your player state. It defaults to a very low value on the player state and can cause delays or perceived lag before changes to things like attributes and gameplay tags happen on the clients. Be sure to enable adaptive network update frequency. Fortnite uses it. Both, the owner actor and the avatar actor, if different actors, should implement the I-ability system interface. This interface has one function that must be overridden, U-ability system component *getAbility system component, const, which returns a pointer to its ASC. ASCs interact with each other internally to the system by looking for this interface function. The ASC holds its current active gameplay effects in F-active gameplay effects container active gameplay effects. The ASC holds its granted gameplay abilities in F-gameplay ability spec container activatable abilities. Any time that you plan to iterate over activatable abilities, items, be sure to add ability list _scope lock above your loop to lock the list from changing, due to removing an ability. Every ability list _scope lock, in scope increments ability scope lock count and then decrements when it falls out of scope. Do not try to remove an ability inside the scope of ability list _scope lock. The clear ability functions check ability scope lock count internally to prevent removing abilities if the list is locked. 4.1.1 Replication Mode. The ASC defines 3 different replication modes for replicating gameplay effects, gameplay tags, and gameplay cues: full, mixed, and minimal. Attributes are replicated by their attribute set. Replication mode: when to use description full single player, every gameplay effect is replicated to every client. Mixed multiplayer, player-controlled actors' gameplay effects are only replicated to the owning client. Only gameplay tags and gameplay cues are replicated to everyone. Minimal multiplayer, AI-controlled actors' gameplay effects are never replicated to anyone. Only gameplay tags and gameplay cues are replicated to everyone. Note: Mixed replication mode expects the owner actor's owner to be the controller. Player state's owner is the controller by default but characters is not. If using mixed replication mode with the owner actor not the player state, then you need to call setOwner on the owner actor with a valid controller. Starting with 4.24, possessed by, now sets the owner of the pawn to the new controller. Up arrow back to top 4.1.2 setup and initialization. ASCs are typically constructed in the owner actor's constructor and explicitly marked replicated. This must be done in C++. This code defines the constructor for the AGD player state class, which is a subclass of a player state. Here's what happens inside the constructor. The ability system component variable is initialized by creating a new instance of UGD ability system component using create default subobject UGD ability system component. This function is commonly used in Unreal Engine to create subobjects that belong to an actor and are initialized during construction. The name ability system component is assigned to the created subobject, which helps identify it in Unreal Engine's object system. The set is replicated, true, function is called on ability system component to enable replication. This ensures that the ability system component is synchronized across the network, making it available on both the server and clients. The comment // suggests that additional initialization logic might be present but is omitted in this snippet. In summary, this constructor sets up an ability system component for the player state, making sure it exists and is replicated properly for multiplayer gameplay in Unreal Engine 5. The ASC needs to be initialized with its owner actor and avatar actor on both the server and the client. You want to initialize after the pawn's controller has been set, after possession. Single-player games only need to worry about the server path. For player-controlled characters where the ASC lives on the pawn, I typically initialize on the server in the pawn's possessed by function and initialize on the client in the player controller's acknowledge possession function. Explanation of the code. This code consists of 2 functions, APA character base, possessed by, and APA player controller base, acknowledge possession, both of which are related to possession logic in Unreal Engine's gameplay ability system, GAS. 1. APA character base, possessed by, a controller * new controller. This function is called when a character, APA character base, is possessed by a new A controller. Call to super, possessed by, new controller. the base class, a character or another parent class, implementation of possessed by is executed first to ensure proper initialization. Check if ability system component exists. If ability system component is valid, i.e., not null, it initializes its ability actor info using init ability actor info, this. If the cast is successful, meaning the pawn is of type APA character base, execution continues. Initialize ability system component. The function retrieves the ability system component from character base using getAbilitySystemComponent. System component. It then calls init ability actor info, character base, linking the character to its ability system. Commented out //. This suggests that additional logic might be implemented in the full code. Key takeaways: possessed by, a controller asterisk, on the character initializes the server-side ability system component when the character is possessed. Ensures the ability system component's owner's owner is the a controller for proper replication. Acknowledge possession, a pawn asterisk, on the player controller initializes the client-side ability system component after the player controller acknowledges possession. Ensures the ability system component is properly linked to the character on the client. These two functions together ensure that GAS works correctly in both server authoritative and client predicted scenarios. For player-controlled characters where the ASC lives on the player state, I typically initialize the server in the pawns possessed by function and initialize on the client in the pawns on rep_player state function. This ensures that the player state exists on the client. This code defines two functions, possessed by and on rep_player state, in the AGD hero character class, each handling gameplay ability system, GAS, initialization for different scenarios, server only and client only. 1. AGD hero character, possessed by, a controller asterisk new controller, server only. This function is called on the server when the character is possessed by a controller. Step-by-step explanation. Call to super, possessed by, new controller, executes the base class implementation of possessed by to ensure the default possession logic is carried out. Retrieve the AGD player state. The function retrieves the player state associated with the character using getPlayerState AGD player state. Check if player state is valid. If the player state, PS, exists, continue with the GAS initialization. Set the ability system component, ASC, on the server. The ability system component is retrieved from the player state by casting the result of PS-getAbilitySystemComponent to UGD ability system component. This links the character's ASC to the one stored in the player state. Initialize the ASC actor info. The init ability actor info, UObject asterisk owner actor, a actor asterisk avatar actor, function is called on the ability system component. This links the ASC to the player state, owner actor, and the hero character, avatar actor. This step ensures that the server-side ASC is properly configured. Additional note, AI-controlled characters might not have player controllers. To account for this, the ASC is reinitialized here. Initializing it twice, for player-controlled characters, doesn't cause any issues. 2. AGD hero character, on rep_player state, client only. This function is called on clients when the player state is replicated, updated, from the server. It ensures that the client-side ASC is properly linked and initialized. Step-by-step explanation. Call to super, on rep_player state, executes the base class implementation of on rep_player state to handle default replication logic. Retrieve the AGD player state. Similar to possessed by, it retrieves the player state using getPlayerState AGD player state. Check if player state is valid. If the player state, PS, exists, proceed with GAS initialization for the client. Set the ability system component, ASC, on the client. The ability system component is retrieved from the replicated player state in the same way as on the server. This ensures the client has a reference to the same ASC as the server. Initialize the ASC actor info. The ASC is initialized with init ability actor info, PS, this. To link it to the player state, owner actor, and the hero character, avatar actor, on the client. Key point: server versus client responsibilities. The server initializes the ASC in possessed by when the character is possessed. The client initializes the ASC in on rep_player state when the player state is updated. Why initialize on both? The server handles authoritative logic and sets up the ASC for its use. Clients need their own ASC setup to handle prediction and local logic. Handling AI characters. Since AI characters might not have player controllers, the server ensures that their ASC is initialized redundantly in possessed by. This avoids potential issues with missing initializations. Replication logic. The ability system component is retrieved from the player state because the player state is replicated across the network, ensuring consistency between the server and clients. Summary: possessed by, server only. Sets up the ASC for server-side use, initializing its link to the player state and the character. Handles special cases like AI without player controllers. On rep_player state, client only. Sets up the ASC for client-side prediction and local gameplay logic after the player state is replicated. Both functions work together to ensure the GAS is fully functional on both the server and clients in a multiplayer environment. If you get the error message log ability system, warning, can't activate local only or local predicted ability %s when not local, then you did not initialize your ASC on the client.